So students, today we will discuss about the classification of solids on the basis of energy band theory. Okay. So what is energy band? The electrons in the same orbit exhibit different levels. The grouping of these levels is known as energy band. Okay. So, what is energy band theory? The energy band theory is a theory that explains how electrons interact in solids, and it is also describes the electrons how energy levels of electrons in solids are closely spaced and from the bands. Okay. On the basis of energy band theory, on the basis of energy band theory, the solids are classified in three parts. These are conductor, semiconductor, and insulator. Okay. In energy band theory, we consider the valence band, conduction band, and forbidden gas. Okay. So let's start the classification. Now you can see the diagrams. This is conduction band and this is valence band. This is the diagram of insulator. This is the diagram of semiconductor. This is the diagram of conductor. Okay. Then, according to the energy band theory, we have valence band and conduction band. Okay. And these bands are separated by forbidden gap. Okay. And it is also called as the energy band gap. Here, in case of insulator, the energy band gap is high or more. Okay. In case of semiconductor, the energy band gap is less. Okay. In case of conductor, there is no energy gap. Okay. If the forbidden gap is more or higher and its value is 5 electron volt. Forbidden 5 electron volt. Okay. In case of semiconductor, the forbidden gap is less. Its value is 0.34 silicon, 0.74 germanium. Okay. In case of conductor, there is no forbidden gap. Okay. So, what is forbidden gap? The forbidden gap means all the electrons are tightly bound with the nucleus. Okay. So, there is no free electrons for the conduction. If we apply more than 5 electron volt to the material, so what happens? That is not converted into a conductor. Okay. Suppose we consider an insulating material, that is wood or rubber. Okay. And give more heat to the material or more electrical energy to the material will get spoiled. The structure will spoiled, but that is not converted into a conductor. Okay. So the conversion of insulator to conductor quite difficult. So in case of conductor, there is no forbidden gap because the overlapping of valence and conduction band. Okay. So in case of insulator, the valence band is fulfilled and the conduction band is empty. The valence band VB is fulfilled and the conduction band CB is empty because there is no free electron for the conduction. Okay. In case of semiconductor, the valence band VB is fulfilled partially filled. And conduction band CB is partially filled, partially or empty. If the insulating material is below room temperature, means the insulating material temperature of insulating material is less. Okay, so all the electrons are tightly bound to the nucleus. So we can say the valence band is partially or fulfilled. Okay, when we get this material at a higher room temperature, some covalent will breaks and the electrons are moves from the covalent bond. So we can say the conduction band is, or we can say it is partially filled. Okay. Then conductor. In case of conductor, there is no forbidden gap because the overlapping of valence and conduction band. Okay. So electrons are freely moved from the valence to conduction band. Okay. So the conduction band is partially filled. Okay. Then the examples of conductor, semiconductor and insulator. Okay. For the example of insulator is wood and rubber. The example of semiconductor is, for the better example of semiconductor is silicon and germanium. Okay. And the example of conductor is copper, aluminum, silver and gold. Okay, so this is the classification of solids on the basis of Reynolds band theory. Okay, thank you.